Have you ever wondered why we dream? What are these mysterious stories that play out in our minds while we sleep? Dreams, those fascinating narratives that captivate our minds during slumber, are a universal human experience. From the most mundane scenarios to the wildest adventures, dreams transport us to a reality of our own making, a mirage that dissipates as we awaken. Dreaming is as common as breathing, yet it remains one of the most puzzling phenomena in the world of neuroscience. Each night as we surrender to sleep, our brains embark on a journey of their own, a journey into the realm of dreams. But what triggers this journey? What compels our brain to weave intricate tales as we sleep? The answer lies in the intricate dance of neurons and chemicals that takes place within our brain. As we drift into sleep, our brain transitions through various stages, each characterized by distinct patterns of brain waves. It's during the rapid eye movement or REM stage when most dreaming occurs. This is when our brain is almost as active as when we are awake, and yet our bodies are in a state of near paralysis, a phenomenon known as REM atonia. Here, in the theater of our mind, dreams are born. They are the product of our brain's attempt to process emotions, memories, and experiences. They are the echoes of our waking life, reverberating in the silence of sleep. Yet, they are more than mere echoes. They are a mirror, reflecting our deepest fears, our highest hopes, and everything in between. The science of dreams is a fascinating blend of psychology and neuroscience. It probes into the very essence of human consciousness, offering glimpses into the mysterious workings of our mind. And yet, despite centuries of study, dreams remain shrouded in mystery, their full significance yet to be unraveled. Just as we've scratched the surface of this captivating topic, let's delve deeper into the science behind our dreams. Dreams are not just figments of our imagination, they are a complex interaction of neurochemical processes. Let's delve into the fascinating science of dreams, shall we? The brain is an intricate network, and different parts play various roles in the phenomenon of dreaming. The limbic system, which includes the amygdala and the hippocampus, is the emotional center of our brain and plays a crucial role in dream generation. Meanwhile, the frontal cortex, our rational thought center, takes a back seat during dreams, which is why dreams can often seem illogical or bizarre. Now let's talk about the stage of sleep where dreams mostly occur, the rapid eye movement or REM stage. During REM sleep, our brain activity escalates, looking quite similar to when we're awake. It's no surprise then that this is the stage where vivid, narrative dreams often occur. But here's the catch. Even though our brains are buzzing with activity, our bodies are essentially paralyzed, a phenomenon known as REM atonia. This is nature's own safety mechanism to prevent us from acting out our dreams. Now, what about the chemicals that make this all happen? Neurotransmitters, the brain's chemical messengers, play a significant role in shaping our dreams. During REM sleep, acetylcholine levels spike, enhancing brain activity, while serotonin and noradrenaline levels drop, contributing to that bizarre, dreamy state. Interestingly, our dreams are not just random. They are influenced by our waking life experiences, thoughts, and emotions. Ever noticed how a stressful day can lead to a nightmare? That's your brain processing your emotions and experiences in the form of dreams. But there's still so much we don't know about dreams. Scientists continue to explore the mysteries of why we dream, how we dream, and what our dreams mean. It's like a puzzle that we're still trying to piece together. So, now that we know how dreams occur, let's explore some theories on why we dream. Buckle up, because the world of dreams is a fascinating, complex, and sometimes downright strange place to delve into. From Freud's psychological interpretations to Hobson's activation synthesis hypothesis, theories about why we dream are as diverse as the dreams themselves. Let's start with Sigmund Freud, the father of psychoanalysis, who believed that dreams are a window into our subconscious. He proposed the theory of wish fulfillment, arguing that we dream to satisfy urges and desires that are socially unacceptable or repressed in our waking lives. Dreams, in this view, are like a safety valve for these hidden desires. Then, we have the information processing theory, which suggests that dreams are a way for our brains to sort through the day's experiences. Like a computer processing data, our minds use dreams to organize, interpret, and store memories. This theory aligns with the fact that during REM sleep, when most dreaming occurs, our brains are particularly active in areas associated with learning and memory. Now let's move on to a more biological approach. In the late 20th century, neuroscientists Alan Hobson and Robert McCarley proposed the activation synthesis hypothesis. They suggested that dreams don't actually mean anything at all. According to them, Dreams are simply the brain's way of interpreting random electrical impulses occurring during REM sleep. The bizarre and often nonsensical nature of dreams, they argue, is a result of our brains trying to create a coherent story out of these random signals. However, it's important to note that none of these theories have been universally accepted. Each has its strengths and weaknesses, and each offers a unique perspective on the enigmatic phenomenon of dreaming. Some researchers even argue that dreams may serve multiple purposes, combining elements from different theories. While the exact purpose of dreams remains a mystery, they are a fascinating testament to the complexity of the human mind. Today, we've embarked on a captivating journey, exploring the science and theories behind our dreams. We've delved into the enigma of dreams, revealing how these nightly narratives are born from the intricate dance of our brain and neurotransmitters. We've discovered that dreams aren't just random images, but possibly a reflection of our subconscious, a creative playground for our mind, or even a rehearsal for real-life scenarios. We've also explored various theories about why we dream. From Freud's psychoanalytic perspective, seeing dreams as a reflection of our deepest desires and fears, to the activation synthesis hypothesis that views dreams as our brain's attempt to make sense of random neural firings. The realm of dreams remains a fascinating mystery, a nightly journey where science, psychology, and philosophy intersect. Dreams continue to fascinate and baffle us, and as we sleep tonight and dream, we can marvel at the intricate workings of our own minds. Until next time, keep dreaming and keep wondering.